Let's take a look at the circuit diagram for including the LED matrix in our project. The joystick connections remain the same as in the previous circuit. Now we will add in the MAX7219.matrix module as part of the circuit. It has 5 connections. The first pin, which is 5 volts, or VCC, is connected to the 5 volt rail on the breadboard. The second pin, which is ground, is connected to the ground rail. Next, we have the DIN pin, or data in, that's connected to pin 11 on the Arduino. Then we have the slave select pin, which is connected to pin 10 on the Arduino. And finally, the clock is connected to pin 13, which is a serial clock on the Arduino for SPI communications. Those are the only additions that we need to make to our previous circuit.
Okay, let's go ahead and make the appropriate modifications to connect our 8x8 LED matrix. This is the MAX7219 dot matrix module. As you can see, we can plug the 8x8 LED matrix directly into here. Let me disconnect it so you'll see what it looks like. Okay, so essentially on the right hand side you'll also see a duplicate of the pins that are on the left, and that's so that we can daisy chain one module to a next to control multiple or several 8x8 matrices. So that's very handy, and this module enables us to control a myriad or multiple LED matrices. So I'll go ahead and connect that back again. On the left hand side, as you'll notice, there are 5 pins. You have VCC, ground, data in, the slave select, and the clock. Okay, just like the joystick, what's handy is on this particular device you have these pins that are sticking out. So we have what makes it easier is if you have these female to male connector pins. That makes it easier to get everything wired up. So I'm just gonna connect those back again. Right, so that's those 3 and then 4, 5. Okay, those are now securely in place. All right, let's begin wiring up our circuit. So first, the VCC goes to 5 volts, so I'll make that connection. The VCC is my yellow wire here. I'm going to connect that to 5 volts. Then we have our ground or black wire here that goes to ground. Next, the data in goes to pin 11 on the Arduino, so that is my purple pin here, goes to pin 11. My slave select goes to pin 10 on the Arduino. And finally my clock goes to pin 13 on the Arduino. Okay, that's it. That completes the wiring for our 8x8 LED matrix. Okay, let's go ahead and upload the code to demonstrate how the joystick works in conjunction with our 8x8 LED matrix. So we'll upload that joystick LED matrix operation program. So I'll go ahead and do that. Okay, so now that program is uploaded, what you'll notice is the dot is being lit at the middle, around the middle of our LED matrix. And now as I move my joystick around left, you can see that the dot moves around. I'm going down, up, right. Okay, so I'm gonna move it in a circle, and as I move my joystick around, what we're doing is we are mapping that, detecting that position, that XY position, XY coordinate for where the joystick is, and we are lighting the appropriate LED on our 8x8 LED matrix. This is pretty cool. So it shows that, you know, with fine-grained control, we're able to determine the exact position of the joystick, and we're able to use that to affect some other external part of our circuit. And in this case, we're using that information to light the appropriate LED in that grid, that 8x8 matrix LED grid. So there you have it.
Let's take a look at the code for our joystick LED matrix operation circuit. So at the top, you'll notice that we have to include a few libraries, and a couple of them are third-party libraries. The first one is the SPI.h, that Serial Peripheral Interface Communication Library. This is included with the Arduino, so you don't have to do anything special to include this. The next one is the Adafruit Graphics Library, and then we have a library to interface with the MAX7219 panel. So for those particular libraries, I will include the links for you to download those libraries as part of the resources, but just to show you, here's a link to the Adafruit Graphics library, and of course we know when you get here, you're going to download the zip file. I'm going to save that to my desktop. All right, and then the MAX7219 panel library, again, I'm going to download that zip file, and I'm going to save that to my desktop. And from there, remember with Arduino, when you go to your preferences, you want to install those unzipped libraries to the libraries folder that's indicated in your sketchbook location. So let's go ahead and do that. If we unzip these, remember you'll have to rename that library, take out the master at the end of it, the dash master. So rename those folders. And then you'd want to copy these in for specifically for me, it's in my documents, Arduino libraries, and here it is. So as you can see, I have those libraries in here already, but this is where you'll want to paste them in. And for you, the relevant path would be indicated by your preferences. You can get that sketchbook location, copy your libraries here, and restart your Arduino IDE. Okay, so with that being said, next let's continue on with the code review. We set up our slave select pin, which is pin 10. We define a couple of global variables, the matrix X and matrix Y variables. These are used to pinpoint which exact LED we want to light on the 8x8 LED matrix. Next, we create the matrix object for which is a MAX72XX panel object. This, of course, we would get this object code from our library that we included. Let's take a look at the documentation for this. We have to first pass in that that pin that we're selecting for the device, and next we pass in a 1 and a 1, which would be the number of vertical or horizontal displays. Let me quickly delve into the documentation here. I'm going to open up the header file so you can take a look at the code for that constructor for that object. So as you can see, it takes in a pin for selecting the device, which is in our case that pin 10. And next we can pass in the number of horizontal displays and vertical displays. So remember, you could daisy chain several of these 8x8 matrix LEDs with the different panels, and the code accommodates for us to connect multiple different configurations and to be able to write to them. So In our case, we're just using one, so we have one horizontal display, one vertical display. Okay, so now we're back to our code. So we set up our matrix object. Then you've seen this code before. Here is for our joystick, the vertical, horizontal, and select pins. I'll move on. Next, in our setup function, we of course turn on that input pull-up resistor. We've seen this before, and here's where we set the intensity of our matrix. So this is how bright we want our LEDs to be displayed. I have set it at a value at 5, and then we begin the serial communications. So continuing on into our loop function, you've seen this before. We get the vertical, horizontal, and select values for our joystick. And here, when we get those values, this is where we begin the process of mapping those values to a corresponding LED on our matrix. So we do a matrix Y, the position of the matrix Y. We want to map the vertical value that we read in, and it primarily is in the range of 5 to 1018. Remember, it's really supposed to be 0 to 1024, but you give a little margin of error there, and we want to map that into a range of 7 to 0 because we address a specific value of a Y, that Y-axis. It has to be in the range 0 to 7 since it's an 8x8 matrix LED. The first index starts at 0. That's why it goes to 7 and not 8. Similarly, for the X position, we want to map that horizontal value that we got in, and we want to map that in the range. Again, we're specifying 1018 to 5, and we're mapping 0 to 7. So that would map the corresponding X value in that range for us. And then the next thing we do is we clear our screen. So using that matrix object, we do a fill screen passing in 0. That would clear our screen for us. And we also would display the output on the serial monitor. This is more informational purposes. You don't necessarily need this, but it's good for debugging if you want to see what the X and Y coordinates are. We then proceed to draw the actual pixel. So we'll pass in the the X coordinate and the Y coordinate. Remember, those values will be between 0 and 7, and we set the value high to actually turn that pixel on. And to finalize that, we do a matrix.write that actually turns it on and displays that pixel. So this is what you need to actually send the bitmap to the display, and this would show the position of our LED. We incur a small delay, and then we actually, this is some code that is left over where we could detect if the joystick was pressed. We aren't actually using this as part of the LED display, but you can incorporate some logic here. Maybe you want to send a message if it's pressed or what have you. This code is still in here, and at least you can respond to button or joystick presses in your code. And that's it. So fairly straightforward. Again, we need the Adafruit graphics library, which works in conjunction with the Max72XX panel library, and that really makes it easy to write to any LED or patterns of any LEDs on the 8x8 matrix display.